All right, if you're getting ready for the NCEE Level 2 probability exam, the 91267 standard, then you have come to exactly the right place. We're going to go way beyond just revision today. We are breaking down the exam, giving you the insider's guide to not just pass, but to absolutely smash it and get those top marks. Okay, let's get into it.
It really all comes down to this one question. Look, most people can do the calculations. That's not the hard part. But the students who walk out with merit and excellence, they're doing something completely different. The secret isn't about harder maths. It's about a deeper way of thinking. And that's exactly what we're going to unlock today.
So, first things first. Before we even think about climbing that ladder to excellence, we got to check our gear. These are the tools, the methods that are totally non-negotiable. You have to have these down cold. Think of this as your essential probability toolkit. You can't even start the climb without them.
Probability trees. Okay, these are your roadmaps. Anytime you have a problem with multiple stages, especially when the odds change as you go, like pulling marbles from a bag and not putting them back, this is your go-to. Just remember the golden rules. You multiply along the branches for one specific outcome, and you add up the different branches if there's more than one way to win. Simple as that.
You know that feeling when the exam just hits you with a massive wall of text, data about different groups, different choices, it's just a mess? Well, this is your chaos to clarity tool. A good two-way table lets you cut right through all that noise, organize the information perfectly, and spot the relationships between things in a heartbeat.
Now, what about questions with continuous data? Stuff you measure, not count. Things like height, weight, or time. Well, that's when you enter the world of the bell curve. And listen, the key here isn't just knowing the theory. It is being a master of your calculator's normal functions, the CDF and the inverse normal. That is absolutely where marks are won and lost.
And finally, we've got the tool that really starts to separate the achieved from the merits and excellences, risk and relative risk. This is where you stop being just a calculator and you start becoming an evaluator. When you see a claim in the exam, something like Group A is 3 times more likely to, this is the tool you use to prove it or disprove it with evidence. This is you thinking like a real statistician.
Okay, so our toolkit is packed, we're ready to go. Now for the main event. How do we actually use these tools to climb from achieved, up to merit, and all the way to that excellence peak? This right here is the absolute heart of what we're talking about today.
See, the journey up the grades isn't about doing more calculations. It's about the quality of your thinking. At Achieved, you just have to apply a tool correctly. For merit, you need to show relational thinking. That means connecting a few ideas or steps together. But excellence, that demands extended abstract thinking. That's the ability to step back, justify your choices, and even critique the whole process.
And this slide just lays the difference bare. An achieved answer, it calculates a number, and that's it. An excellence answer takes that very same number and asks, okay, but why was this the right tool to use? Is this statistical model I used even a good fit for the real world? And how does this result actually prove my argument? The calculation for an excellent student is just the starting line.
And here's a perfect example. Let's take a two-way table. For achieved, you find a probability. Boom, done. For excellence, you use that same table to calculate relative risk, write a whole conclusion about a claim, and then justify your entire position using statistical evidence. It's the same tool, but it's being used at a totally different level of thinking. It's not about the table itself. It's about the powerful story you tell with the numbers inside it.
Which brings us to the secret weapon, the one thing that consistently gets students those top marks. And it's not another formula or some complicated new method. No, it's a mindset. It's a specific way of thinking that the examiners are actively looking for.
Getting to that top tier is not an accident. It's a process. It is a habit that you need to start building right now. After every single important calculation you do in that exam, you need to learn to just pause for a second, take a breath, and ask yourself 2 absolutely game-changing questions.
And here they are. First, so what? What does this number actually mean? Don't just write down 0.28, right? This means there's a 28% chance that you have to link it back to the real-world context. And second, and this one is the big one, what are the flaws here? Did I just assume these events were independent? Is a normal distribution really the right model for this data? Could there be some kind of bias in how this data was collected? Answering these 2 questions, that is what excellence sounds like on paper.
Okay, let's switch gears. It's time for a rapid-fire round on how not to lose marks. These are the classic mistakes, the common traps that students fall into year after year. Just knowing what they are is half the battle.
Okay, listen up. Rule number 1, do not, under any circumstances, round your numbers until the very final answer. 2, and means you multiply along a branch, or means you add different paths. Get it? Right. 3, the probability of A given B is not the same as B given A. You have to read the question so carefully. 4, never just assume things are independent unless you can back it up. 5, on a tree diagram, if there's more than one way to get what you want, you have to add those paths together. And finally, a number without context is just a number without marks.
So, we've got the tools, we've got the mindset, now let's pull all of this together into a clear, simple strategy that you can walk into that exam room with feeling totally confident.
This right here is your final check-in. The night before the exam, I want you to look at this and ask yourself, can I turn a messy paragraph of data into a perfect two-way table? Can I draw a tree diagram where the probabilities change at each step? And do I know exactly when to use inverse normal instead of normal CDF? Most important of all, do I remember those 2 big excellence questions to ask after I do my calculations? If you can say yes to all of that, you're not just prepared, you are dangerous.
And that's really the whole game plan. Just remember this one thing. The exam is there to test your math skills, sure, but merit and excellence, they are there to test your thinking skills. It's all about justification, communication, and critiquing the process. So walk into that exam ready to show them not just what you can calculate, but how you can think. Now go get it.